So also anything covering average rate of return, that's in, I think, the last section of chapter 6. That's one of the sections we skip because it's a kooky, crazy formula involving what we call an nth root. Now, I know that y'all know how to do square roots, but I don't know that you've been taught how to handle what we call the nth root, which is like a cube root or a fourth root or a fifth root. And yeah, it is what it is. It's a really awesome formula. But if you see any of it in the homework, we didn't cover it in class, so you skip it. If for some reason it's on a test question, which it wouldn't be, then you'd skip it. So again, we can get APY, annual percent yield, given an APR, but we can't find APR given an APY based on what we've been taught. I gave you a formula for APY last time, and when I gave that formula, I said, we can find APY given APR, the annual rate, but we can't do it the other way because it involves something called a natural logarithm. Or, sorry, not a natural logarithm, just a logarithm. And we aren't teaching you that in here. It's not part of our curriculum, so we don't do it. But the formula I gave you last time doesn't involve that stuff, so we can do it. So again, if you're given APR, you can find APY, but not vice versa. And I meant to pull up the text example. That's cool. I have this open still because we're going to need this. Okay. And we'll get into this a little bit in just a few minutes. So chapter 8 is all about curve fitting and correlation. That's the title of chapter 8. Curve fitting and correlation. So we've already seen some of these ideas, and I've already mentioned the R-squared concept in the past. So we've had, you know, let's not even do it as a two-dimensional setup. I mean, as a full plane setup. Let's just say we had some data, and all the data points look like this. And then we say, all right, well, we type that in Excel, we get a scatter chart, and then from there, we say, all right, Excel, make an equation for me, and we say, make a linear model, that line of best fit that we've talked about. And Excel probably makes something like this. What? That was weird. So Excel makes that the line of best fit. But as we're getting into exponential growth, our data might look something more like this. And again, the real world data, not necessarily I lost my train of thought. So this would be the real world data. And then we tell Excel to make a curve of best fit. And when Excel makes that curve of best fit, it probably looks something like this. Now, they might still call it a line of best fit because of the method name, but it's a curve, so I'd call that a curve of best fit. That's when you do a exponential linear regression model. And that just sounds silly because lines and exponentials aren't the same thing. But if you did a line of best fit, the line of best fit, as we've seen, ends up looking something like this. And I'm going to erase all of that in just a second, because you can see that these data points don't model very well. These data points don't model very well. So you don't really want to model things that look like exponential trends in a linear trend. And that's an important concept if you're going to be modeling data. It's one of the things that we like you to be able to do as QR students. Can you look at a pattern and tell, hey, should you use a line of best fit? Or maybe you do need a curve of best fit, probably exponential. Now, there are other curves of best fit like quadratics and other polynomials, and I'm not even going to get into all the types. The two things we focus on here, because they're the two seen the most in the real world related to finance and related to just, you know, basic things around us, are lines and exponential curves. If we were talking about throwing a ball in the air, that would be a parabola or a quadratic. But we're not that interested in that kind of stuff in here. I mean, it's good, but we're more, you know, finance-based, I want to say, at least the last half of the course. Okay, so what was the point of these two discussions? Correlation has to do with how well these dots are fitted by the line of best fit or curve of best fit. So correlation is how well these dots fit their model. So the red line or the red curve would be the model, the thing that Excel builds for us based on the data, doing all that crazy math that we don't want to have to do. So the first thing we have to get into in this discussion is probably, I don't want to say the most difficult to discuss, because it's not that difficult to discuss, but it is extremely difficult to prove a link between these two things. And that's half of the difficulties with modeling in our world and trying to say that one thing leads to another, especially when you talk about human dynamics such as population or health, dietary needs, things like that. So again, holding off on the C example, I should have that a little lower. I need to edit this file. That's okay though. So correlation versus causation. What are they? How do they relate to each other? How can we say one leads to the other? Okay. Causation, the root word there being cause, because of this, something else. So a causation is a change in one variable causes a change in the other. This is known as a direct effect. Causation means A causes B. If A, then B, if you want to get into logic statements. So causation, a change in one variable causes a change in the other. And when I say variable, I just mean a change in something. So for instance, I have a glass of water next to me. If I pick up my glass of water and I drink it, I'm hydrated. So the glass of water and me drinking it, that would be a change. That would be me, hey, say, I wasn't drinking water, now I will. And what does it cause? It causes hydration. I just added water to myself. So that would be causation. One thing caused another. Me drinking water caused my hydration level to go up. I know that's silly, but it was right in front of me, so I had to use it. This would be better if it was in a class and the silliness would show. Okay, so causation means one thing causes another. Correlation. An increase in one variable also sees an increase or decrease in the other variable. Now this one is very interesting, and at first glance you might say, well, that's causation. It's not. An increase in one variable also sees, it doesn't say causes, it just says that you also happen to see something else increase or decrease consistently. So whether it could be one thing goes up and the other thing goes up, or it could be one thing goes up and the other thing goes down. What you want to see is that being consistent. So that's kind of related to being proportional or inversely proportional. Proportionals means as one thing goes up, the other goes up. Inversely proportional means as one thing goes up, the other goes down. So correlation is two sets of things kind of obeying the same pattern, but not necessarily one thing is causing the other. So causation means thing A is making thing B happen. Correlation means thing A and thing B are happening and they're correlating, which means they are growing or shrinking in similar fashions. And again, one could be growing and the other could be shrinking. For example, if you nail down your accelerator in your car, you're going to decrease your fuel consumption. And spoilers, that's causation, not just correlation. So the correlating factor is you're pressing your gas pedal in more, and then your fuel consumption rate goes down. You might go from, say, 30 miles per gallon to 20 miles per gallon because you're using more fuel, and it's not going to be as efficient. So that's the correlation. One thing goes down and the other goes up. The harder you press, the lower your fuel consumption rate goes. So one thing's increasing and the other thing's decreasing. But it is causation in that issue. But if I didn't tell you it was causation, you might have to do some research to prove that that correlation is indeed causation. And that research and the proving of causation is the difficulty I'm talking about. Now, in a study related to that, it's not so bad. It's pretty easy to use physics and chemistry to show that outcome that correlation is causation. But when we're talking about, person B or person A, whatever, I don't want to say person B, person A increases their fat consumption, and then you also see that person have more health problems. So you might say, oh, okay, well, an increase in fat consumption causes health problems. So your health to decrease. So increasing fat decreases your health. But the problem is, while that data may correlate, you may see these things happen. Person A, person B, person C. So person A eats a little fat, person B eats a lot of fat, person C eats a ton of fat. And then you might see their health ratings. Let's just call it a flat number. Person A has a health rating of 97. Person B has a health rating of 79. And person C has a health rating of 22. I don't know. So you go, oh, okay, well, that's correlation. As you increase fat, your health rating goes down. So, well, I guess eating fat makes your health worse. That's the causation someone would try to say. But let me tell you, proving things with human beings and their diets and body chemistries and all this crazy, crazy, crazy amount of what we call confounding factors, these hidden issues, you can't just say that blatantly because, okay, you were looking at the fat consumption. Did you look at their sugar consumption? Did you say that they were all eating the same amount of sugar? Did you say that they were all doing the exact same thing across all other macros? Are all three of these people from the same region? Are they of European descent? Are they of Asian descent? Are they of African descent? There's a lot of research coming out now that says where you come from, basically, can have an effect on your dietary needs. And again, I'm not saying any of this is fact or fiction. I'm saying there are studies that are doing this. But again, there's a lot of information out there that tries to say thing A causes thing B, when in fact, we don't really know, haven't proven it, or may have even made a wrong causal statement being A causes B. So this is every statistician's favorite statement. I'm not a statistician, I'm a mathematician, but I still like it. Correlation does not imply causation. You find any book on statistics, you can find that statement in there somewhere. Correlation does not imply causation. Just because two things are, having the same pattern or opposite patterns does not mean that one thing is actually causing the other. They could both be an effect of something else, or they could just be random correlation. Just because somebody has data with similar trends does not mean that one caused the other. Just because somebody has data with similar trends does not mean that one caused the other. They can correlate, but it doesn't have to mean there's causation. So again, holding off on the Walmart example, I like this little silly, example I'm about to do. So here's an example of correlation versus causation. Since the 1800s, the pirate population has been steadily shrinking. Fact. Since the 1800s, the pirate population has been steadily shrinking. We've become more civilized. Not a lot of people are just sailing the open sea constantly, but they still are out there. They're a very, very small subset of the population, what it used to be, 1700s, 1800s. So since the 1800s, the pirate population has been steadily shrinking. So, hold on. And I don't know if it's a linear trend. I don't know if it's an exponential trend. But if we had time versus the number of pirates, if this was our 1800, and let's say this is 2000, it's probably gone something like this. And I'm not going to put numbers up here. Maybe this is 10,000, maybe this is 20, but this is what it would look like. Maybe it would be linear, maybe it would be a more drastically steeper curve at the beginning and flatten out super quick. The idea is there. Okay. Since the 1800s, the average global temperature has been steadily increasing. Once again, fact. Since the 1800s, our global temp has been steadily increasing. So maybe the average global temperature was, I don't know, 60 degrees Fahrenheit back in here. So we'll call this 60. And again, I'm not actually putting a number up here because I don't know the average global temperatures. I didn't look them up. It's not the point of this. And over time, a lot of people would say due to humans being on the planet, but that causation effect is very, very heavily studied. Anyways, we're not talking about humans. Over time, that temperature's slowly increased. Now, maybe this is 60 versus 62. Maybe it's 55 versus 80. But again, the point is it's increasing. Okay, so since the 1800s, the pirate population has dropped. Since the 1800s, the temperature has increased. Okay, well, this thing has consistently gone down. This thing has consistently gone up. That's correlation. That's one thing decreasing and the other thing increasing. So what someone might do on some fake news, Facebook media, whatever, is say, thus pirates caused global warming. OMGZ, LOL, BBQ, if you can't figure out what that stands for. Again, the whole point of this problem is silly. The Z doesn't actually stand for anything. Zany, if you will. So again, there are people out there that would publish this, and that's sadly not a joke, that pirate population shrinking is what caused the global temperature to increase. Can you imagine saying that? And it is 2020. We say some weird things in 2020, and there's some weird things going on in 2020. But I just don't think that pirates were keeping the global temperature down. That's what this statement is saying. It's saying that somehow the pirate population shrinking has somehow caused the temperature to increase. So pirates were doing some kind of, let's just say, mathemagic to keep the global temperature down. So as pirates are dropping, the temperature is going up. You lose another pirate, the temperature goes up. You lose another pirate, the temperature goes up. Again, this is wrong. This is not wrong. Pirates decreasing did not cause the global temperature to increase. Confounding factors are what's going on between these two things. These are the real, often hidden variables behind correlation. And then again, more silliness. I don't know why I got so silly in this chapter. I just felt like it. I know confounding factor sounds like a Scooby-Doo term. If it wasn't for those confounded teenagers, I'd have gotten away with it. So no, that's not what that is. Confounding factors are the actual causation factors. But they're often hidden, and again, this is what researchers spend their time trying to find, the real link, the real cause. So why did the pirate population shrink? What are the confounding factors there? And again, we were using the pirate shrinking as the dependent variable before. Now I'm calling it, as the independent. Now we're calling it the dependent. So you might say, okay, well, what caused the pirate population to shrink? Maybe it was human beings becoming more civilized over time, human beings having cities and living in denser areas and stuff like that. What caused the temperature to increase over time? There's a lot of theories that say our pollution has caused it to increase. Some people might argue that just having an increased population of people here altogether is causing it because we have so much more density versus before. Maybe it's the cutting down of the trees. Maybe it's all of this stuff. And again, I'm not saying that it's A or B or C. I'm saying, hey, these are things you have to think about. But it's definitely the blue thing didn't cause the red thing. There's a reason pirate populations are shrinking over time. There's a reason the global temperature is going up over time. And some people might say the human beings aren't having an effect on the global temperature rising. Some people might say it's just the Earth and its natural waxing and waning, if you will, in terms of global temperature. We've had ice ages, we've had hot ages. Maybe it's just a fluctuation there. But then you'll get some people saying, well, this fluctuation is happening really quickly versus in the past it happened over long periods of time. Okay. So let's get into Walmart. This is one of my favorite problems from the book. Again, these are all just examples, no discrimination against anybody, love everybody. So don't think we're just picking on obese people with this. So the spread of Walmart supercenters is linked to obesity, read the March 9th, 2001 Harvard Business Review Daily Stat headline. I mean, came from Harvard. Daily Stat headline. Jeez, I'm going to believe that right now, right? Well, yeah, in 2020, probably a lot of people will. And I'm not saying they wouldn't in the past either. But let's dig a little deeper. Caption went on to state, research suggests that one additional Walmart supercenter per 100,000 residents, and to give you kind of a scope, Portsmouth has about 100,000 residents. So if we added one Walmart to Portsmouth, which we did about, 7 years ago, not too far from TCC. So research suggests that if you add one Walmart per 100,000 residents, it increases an individual's probability of becoming obese by 2.3 percentage points. Oh man, they used percentage points. They know what's up. They know what they're doing. Clearly all of this is right. I mean, if you see the phrase percentage points, they have got their act together. No, the point of this is no. People like to use fancy language to make them sound smarter than they might be, to back up what they're stating. So, okay, you see percentage points and your brain might go, these are clever people. They know what they're doing. Just because you know a term doesn't mean you know how to link causation. Okay, so the researchers published in this journal say the study implies the proliferation, which means if Walmarts keep increasing in number and spreading over America or whatever country we want to talk about, of Walmart supercenters, which offer food at highly discounted prices. Also, I don't know about y'all, and I stopped shopping in Walmart about 5-6 years ago for various reasons. But when I was in Walmart 5-6 years ago and I'd go to Kroger or Food Lion, the prices were pretty much the same on like your normal packaged groceries. Now, your meat counter might be different, your seafood might be different, things like that. But I really don't remember seeing a massive difference in prices of specifically Kroger versus Walmart. Now, Harris Teeter I know is a little pricier if things aren't on sale. Food Lion's, kind of mid-range as well. But I remember a time when Walmart food was very, very much cheaper than the other places. I remember being in college and driving way longer than I should have to get to a Walmart just to save 30 or 40 bucks on my big grocery bill instead of going to the local store. And I just don't feel like taking that long drive would be worth it now. Now there's more Walmarts, it wouldn't be a long drive anymore, but not the point of the story. All right, so they're claiming that Walmart offering cheap food explains 10.5% of the rise in obesity since the late 80s. So America since the late 80s and even a little further past than that. But we've seen our obesity rate, in other words, the portion of people that are obese in relation to all of the people, that would be the obesity rate. We've seen that number just consistently rise for the past several decades. Please read the caption carefully again and try to understand what the researchers are supposedly claiming. Chapter goes over the mathematics behind such statements. The caption is implying a causal link between supercenters and obesity. Namely, that access to mass quantities of inexpensive, unhealthy food at supercenters contributes to unhealthy weight gain. Supercenters are part of the cause people become obese. That sentence is not worded very properly, I feel like. Supercenters are part of the cause people become obese, is the claim as stated in the caption. This claim seems obvious, but having objective data takes us from the realm of speculation to science. So we're going to look at some data and see if we can link these together or not. Maybe there's something else going on. How much more do I need to read of this? Most definitely can point to a correlation. So there's definitely a correlation. You can very easily find correlation with a lot of things. Again, causation is the key. And we don't really focus on a lot on causation in this course and the homework, but when you're outside of this world, when you're reading random articles on Facebook or, I don't know, whatever social medias post articles, Twitter, I guess. I don't really think Instagram really posts news. It's usually just pictures of food and puppies. I don't know. I'm making blanket statements about things I don't use. Just what I see from other people. So In fact, the researchers are saying that if a city has 2 supercenters per 100,000 people and 6% of these people are obese, then adding another city with 3 supercenters, sorry, not adding, then another city per 100,000 people will have 8.3% of the population obese. They're saying every Walmart is causing about 2.3 percentage point increase. So that's why we went from 6 to 8%. Correlation does not imply causation. It doesn't disprove the researcher's claim of causation, but it does mean that one must carefully read the research. Again, confounding factors are the other possible factors that could cause the observed behavior. Maybe it's just the number of Walmarts are going up and obesity is going up. Maybe there's another reason that the obesity rate is going up besides Walmarts proliferating. For instance, maybe there are more supercenters built in poor areas, and it is true that obesity is higher in poorer regions in general. There is a correlation between the wealth of a region and the obesity rate of a region. Okay. I don't have the textbook pulled up. I have the workbook pulled up. That's okay. So all the same stuff was seen in here. I knew I was reading a lot of things I usually don't read. Okay. I kept looking for this stuff specifically. I was like, I want to do my weird statement. So please read the caption, blah, 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 blah. So previous headlines of this Harvard Business Review daily stat were mobile phone purchases reduce tobacco use in the Philippines. What? So somebody did some research and saw correlation that the more mobile phone purchases someone had, the less they use tobacco. Or you could just say the more people that own phones, mobile phones, the less people use tobacco, and specifically in the Philippine region. So if you buy a phone, you're less likely to use tobacco. That's an interesting correlation, but do you think there's a causation there? Do you think your cell phone's making you not want a cigarette or something? I don't know. That just doesn't sound like a lot of sense. So then they had another article title, Thin Men Get Lower Pay Than Average Weight Men. Huh. Well, that's also weird. So if you increase your weight by 30 pounds, does that mean you're going to get a pay raise? I don't know. I just don't know. So maybe the last one, mobile phone purchases reduce tobacco use. Maybe it's just over time, people buy more cell phones, and over time, people have reduced their tobacco use because we're more consciously aware of the negative impacts of tobacco use on our lives, which are causation, not correlation. There has been research done on that, so don't argue over that one. The thin men get lower pay than average weight men. Well, guess what? As you age, you tend to get more weight on you. And as you age, you tend to make more money. You get better jobs or pay raises or promotions. So maybe it's just the younger people are skinnier and the older people are fatter, and the older people are making more money because of time. And then they do this nice little fun statement. This is my favorite. Apparently, men who are thin from smoking should buy an iPhone in Manila, that's in the Philippines, and move next to a Walmart center in order to get a raise. If you link all three of those things together, if you are a thin man and you smoke, and you don't make much money because you're thin, you should buy an iPhone to reduce your smoking use or to quit, move to a Walmart to get fatter, and then get fatter to get a raise. I mean, that sounds like some 2020 Facebook article, no doubt. Okay. So what's really going on? We've basically already talked about all this. They also talk about how all that precise sounding percentage points. Remember, percentage points is talking about a total change in percents. That was a phrase that we dealt with in 4.3 or 4. I want to say 4.4 very, very heavily. So when you have a total change that's, say, apples to apples, and then the percent change is percent, that's not a problem. It's when you have a total change where your data is percents originally. So we went from a obesity rate of 10% to 12%, for example. That would be an increase of 2 percentage points. You don't want to say 2% because when you do the percent change or the relative change, that's where you'd say percent, and you don't want to confuse yourself. So again, like we were talking about, they use the phrase percentage points. You might go, oh, they definitely know what they're talking about because they know their statements. First of all, they might use percentage points wrong. I've seen that misused in the news. Second of all, just because you use a term doesn't mean that you are using it properly. I can't tell you how many times I hear people use words improperly. Irony, 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 irony. So many people use irony as coincidence. Guess what? Was guilty of it for a long, long time. And then somewhere around 18 or 19 years old, a friend fussed me out over it, and I spent some time and I learned it, and now I get it right most of the time. Sometimes irony and coincidences are hard to tell apart. They could be both. But a lot of times irony and coincidences are not the same. Again, just because you say a word doesn't mean you know what it means. Okay, so let's get into some charts and how they actually were doing this analysis. Where did this information come from? Here is a chart with two completely different sets of data on it, and that is a giant red flag to me out of the gate. Charts should really only have one type of data in them. So just charting a number of apples, or just charting an obesity rate, or just charting percentages, or just charting a total number of people, something like that. We are charting with the dotted line slash curve slash whatever you want to call that, because it's kind of like two different bits. This is the number of Walmart supercenters, and these are tracked on the left heights. So when you're right here, where my mouse is, that means in about 1998, there were about 500 Walmarts in the United States. And I'm saying about because, I mean, it might be like 1998.1 or 500.2, something like that. But then also 1998, I can switch to the other curve, this black solid one, and I can trace the obesity rate back in 1998. So in 1998, when there were about 500 Walmarts, the obesity rate was about right here, which if you trace to the right is 0.3 or 30%. So in 1998, based on what we call obese, 30% of America was obese, which means you are overweight by a certain amount, or your BMI, body mass index, is higher than a certain amount, which first of all, obesity rates are calling some people obese that aren't. BMI tracks your size and like height versus your weight, basically, and a few other measurements. And you can have someone who is just completely ripped, solid muscle, maybe 300 pounds, bodybuilder, and on paper they could be obese because they have so much muscle that this is not accounting for. Now you might say, well, clearly the obesity rate is just terrible then because of all these bodybuilders. They make up a very small portion of the population and are not really messing up the obesity rate. There are still some people that are probably labeled as obese that shouldn't be labeled as obese, but I don't think that it's going to cause more than 1% error. If you just actually did it more appropriately, which is when you study how much muscle, how much fat, how much bone, all of these things a person has, which is a little more involved and why it's not done that way. They like to put people in water tanks. You might see some special scales, and you can get calipers and all sorts of studies. Again, I'm getting sidetracked. So the reason I don't like this two-way chart, if you will, this two-sided chart, is because somebody decided, or Excel decided, that the left side was going to go from 0 to 2,500 in terms of number of stores, and the right side was going to go from 0 to 40% in terms of obesity rate. Now again, maybe a person decided that because then the picture really paints a picture of what they're trying to demonstrate, and which is this causation. Excel probably picks it just because it can get all the data on one screen, but people pick things so that it will mimic what they're trying to go along with. Now, if I make the obesity rate of 40% down here, so 0 to 40% is all in this range, that means that this black curve thing, the solid one, would be all down here, and then the Walmart supercenters would be all up here. It would look like Walmart supercenters are just exploding, and the obesity rate wouldn't actually look that bad because it's only taking up a small chunk of the graph. It wouldn't even be anywhere up here. Oh, that's not bad. Well, actually it is, because it's just 0 to 40% is all down here, so it doesn't represent a great image. Or maybe you go the opposite way and you call where the 0.4 is 10%, so now the obesity rate looks like it's way higher than the Walmart supercenters. So again, the point is, this type of graph or chart with two types of data that have nothing to do with each other except maybe correlation, this is terrible and a great way to misinform or confuse the masses. Okay, so when you look at this, you see, oh, the obesity rate's going up over time. Oh, look at this, the number of Walmarts is going up over time. So clearly one caused the other. Now, well, maybe it's the rising obesity rate, maybe that caused the Walmart centers to proliferate. Who says it can't be that? Who says it can't be America becoming more obese and thus we need more Walmarts? Why is it more Walmarts are causing more obesity? You know, which way is the causation? And that's something else that people get backwards often. So how can we look at this picture, dissect it, and say, I don't think Walmarts are causing the obesity rate to increase. So let's check this out. I'm grabbing my real pen. I'm about to draw on my tablet unintentionally. All right. So this region right here is completely flat on Walmarts. And that's because Walmarts didn't really come around until 1988. Now, you might look at this graph and say, well, it doesn't really lift off the graph until 1993. This is about where it stops being completely flat and picks up. Well, why, if there were Walmarts in 88, why didn't you see a bump sooner? Well, because this is 500 Walmarts, so it's going to be really hard to demonstrate 1 or 2 or 3 when only up here is 500 of them. So why does it start being able to visually see the lift off around 93, 94? Because the Walmarts started in 88, they made a decent amount of profit, so they opened a couple more. So by 1993, there were 10. And then those 10 super centers, they were doing so well that they were able to leverage that money to open up another 50 or so Walmarts, and then it just kept spiraling and spiraling from there. So it's a compounding effect. You use the money from your other stores to make new stores, then more stores and old stores make new stores, and you get the idea. It's the same as our money growing over time. So that's why in 1993 there were 10, but only 2 years later, there's 240 of them. And then another 10 years later, there's almost 1,700 of them. So they just explode. So look at what's happening when Walmarts are not proliferating, when they're not growing and growing and growing in number. Look at this. The obesity rate up to that point was steadily rising. It was very, very, very steadily rising. Now, there's a small little bump here around 92. The rate, the slope doesn't increase just a smidge, but that's a very minor effect. So before Walmarts were around, the obesity rate was already rising. That is the first clue that Walmarts aren't causing the obesity rate to rise, because the rate was already going up before Walmarts were really around. Then Walmarts explode onto the scene, but look at the obesity rate here. So now let's split it up here. When we have this explosion of Walmarts, if Walmart's truly causing the obesity rate to increase, this explosion of Walmarts should cause the obesity rate to increase. But this right here, this region, is pretty much the same slope as this region. In fact, it flattens out for a little brief moment around 2001, 2002. I don't know if it's a coincidence that Super Size Me came out around that time frame, which, if you're not familiar with that movie, it was Morgan Spurlock, I think is his name, ate McDonald's for a month and decided that his body didn't really like it, so he gained a bunch of weight. He had some minor health issues, but that was just 1 month, not years and years and years of it. So he's like, okay, I probably shouldn't eat so much fast food, which again, it was for science and entertainment purposes. So a lot of people may have seen that and said, I'm going to chill out on the fast food. And again, I don't know, maybe that's just a coincidence. Maybe it's correlation and not causation. I only bring that up specifically because I know I saw that movie back in college, and it made me stop eating fast food altogether for quite a long time, and I still haven't had McDonald's in almost 20 years. Outside of one time because it was an emergency. Again, not the point of the problem, but I like little fun side stories. Okay, so this, again, the explosion of Walmarts, but then the obesity rate not really changing in terms of its slope. The rate of the obesity rate was not changing. So that says, I don't think Walmarts are the issue. All right, so let's clear our screen. Take off annotate, scroll down. Oh, no, next page. So what else is there? Well, here we go. Yeah. The maps in figure 8.4 and 8.5, that's these. Well, 8.2, 8.3, 8.4, 8.5. I don't know why they say 8.4 and 8.5. I'd go 8.2 through 8.5. Definitely convey a visual correlation between high obesity rates and locations of Walmart supercenters. It's not always easy to see the differences between correlation and causation. And we'll spend this chapter, blah, 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 you get the idea. So again, here's another piece of data, if you will, that tries to imply that causation. So these are called heat maps, the top left, top right, and bottom left. These are heat maps, and they show the obesity rate based on color. So the cooler the color, a white or a blue, would be a lower obesity rate, and your hotter colors, your magentas, your pinks, your reds, those would be your higher rates. So then they say that a BMI of greater than 30 or about 30 pounds overweight for a 5'4" person is what they call obese. So average height of a woman, probably about 5'4", I'd guess. So 30 pounds for a woman. Men, average height's probably 5'10", 5'11", 5'9", something in that ballpark. So because of the increase in height, this is probably closer to like 40 pounds. And again, ballpark number, not the point of the story. So let's scroll this down now so we can see the numbers for the colors. I really want to have this nice and large like that, but I have to zoom out a little for a while. So here are the colors. So if it's white, that means no data actually. I said that poorly earlier. I was thinking white meant 0 to 10 or 0 to 5 or something, but white means no data. So this was 1990, before the internet was really, proliferated. We're going to use that word today. So we didn't have data for Alaska because it's Alaska. No data for a few other states as well. So the rest of these, in New Jersey it looks like. That's weird. So most of these are very light blues or medium blues. So the obesity rates were under 10% or 10 to 14%. And it kind of looks like the East Coast is worst mostly, except Virginia. Then we get to 2000, and people were gaining weight. People were becoming more obese statistically. So now our light blues and medium blues have turned to dark blues, darker blues, and these kind of yellow colors, which I think yellow is between blue and red in terms of a temperature idea. It's a cool color, but it's not hot. It's not icy cold like a blue would feel like. So we got a lot of states in the 20 to 24% region now, especially on the East Coast, up to about halfway through the Midwest. And then a lot of states in the 10 to 20% between these other two blues, but no states are under 10%, it doesn't look like. Then by 2010, things are getting serious. We got a lot of these magentas and hot pinks and dark reds. So we're East Coast 25% up, West Coast a lot of the 20 to 24% ranges, but then also some of the 25 to 29. This bottom right one is not a heat map. This is just the density of Walmarts in the United States. So every blue dot represents some number of Walmarts. I don't want to say it's one Walmart. Let's just say it's some number of Walmarts. It could be 1, it could be 2 or 3. It says 1, but I don't know that this is super accurate because it's really hard to tell how many dots are in this little region right here, even if you zoom in super close. So I don't know. It's just kind of tough to say that that is the case. Also, I only see 2 dots in the Hampton Roads region in 2009. I'm pretty sure that one in Newport News has been there since at least 2009, and there's been more than one Walmart on the south side down here. So that's why I'm saying I just don't know that each dot is one Walmart supercenter. Anyways, so what they try and do is they put all these together, zooming back out, and they want you to correlate that Walmart's causing the problem. Walmart's linked to obesity, at least. Well, look at this. Where is the worst side of the country in each of these? In 90. In 90, it wasn't as big of a deal because there really wasn't any Walmarts. They really just expect you to look at these two. But you still could argue that in 2000. But let's just focus on the 2010. So in 2010, look at kind of splitting the country in half. Look at the left versus the right side. The left side, you don't really see a ton of these blue dots, which means there's not as many Walmarts. Well, on the right side, it looks like chicken pox. Look at all those Walmarts. So clearly, based on this, all these Walmarts are causing this super, super dark red and magenta. And again, that's what they're trying to convey to you. But it doesn't mean it's causation. It could just be correlation. It just happens to be that all these Walmarts are over here and the America is more obese over here. What it really tends to be is that higher density populations tend to be more obese, and Walmarts tend to go in higher density populations. Who's going to put a Walmart in the middle of Montana where there's like 7 people living in a 10-mile radius? That would be silly. And if you live in the middle of Montana, I bet you're getting a lot more exercise on a daily basis than if you're living in some city area where you're driving everywhere. You're probably walking or biking or getting more exercise. If you're working on the farm, especially. I was about to make a statement that had to do with another state, so I'm going to disregard that. Let's go to the Dakotas. Maybe you're climbing Mount Rushmore every day. All right. Mount Rushmore is not in Montana. It's in the Dakotas. Okay. But again, the point of this whole discussion is that these pictures are trying to paint a picture to make you think one thing is causing another. You could get into this really heavily now, like, hey, if you wear a mask, does a virus spread more or less? We have seen studies with air molecules, people coughing through a mask, and then we have petri dishes and look at them over time. We see this correlation between whether you should wear a mask or not based on how much is in that petri dish, on whether you wore a mask, whether you didn't, what type of mask you wore. And then you get a lot of people saying that, oh, that's correlation, not necessarily causation. A lot of people might say that, hey, the virus is smaller than your cough particles or the water droplets. And you can get into all sorts of arguments, which is why we have a country of people, half of them don't want to wear a mask. Now, again, I'm not telling you should wear a mask. I'm not telling you what to do in this mask situation. But the point is, lots of things you can say A causes B, but you have to actually do some research to prove that, whether it be reading articles or actually doing the research yourself. But when you're reading these articles, you have to read them, you have to take them with a grain of salt. Lots of people make statements that are not true. They may have data to back it up, but there could be confounding factors that are really causing this. So it's not just Walmart's, it's the proliferation of all the different fast food places. It's the proliferation of cheaper bulk food. It's people eating meals out more than home-cooked meals. It's people not paying attention to our diets, and it's possibly being misinformed on what our diets should be. Now, I throw in the possibly for 2 reasons there, because one, unfortunately, not enough Americans actually follow some diet. And when I say the word diet, I don't mean like you can only eat 1,200 calories a day. I just mean eating a regular amount of food every day that keeps your body healthy at a normal weight, not fluctuating, things like that. Also with good health benefits, blah, 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 blah. Sorry, something's going on at home and I just got distracted. Give me a second. Okay. But there are certain people, we have the food pyramid. Personally, I don't know how much I trust the food pyramid. I've done a lot of reading and research that says a lot of other things. And I'm not going to get into that information because this is not me teaching health science. This is just me saying I question things, you should too. I see a lot of arguments that, meat's bad, meat causes cancer. And then they do these studies where you have people that increase their meat intake and then they're more likely to get cancer, or they did develop cancer, things like that. But the problem is, a lot of the time when people do these studies on food-related things is they don't track everything. And I mentioned this earlier. Okay, their meat consumption increased. What about their sugar consumption? What about their plant-based oils? We're seeing some research now that these these canola oils and things like that, they might not be the best thing for our hearts. Saturated fat versus unsaturated fat. Eggs, good Lord, eggs. How many times have they been good for us, then bad for us, then good for us, then bad for us, based on some studies, based on correlation, maybe not causation? I don't know how many years it's going to take for us to get the science of health and what we should be eating down. I don't know that we'll ever have it down, honestly, because, in my opinion, there's a lot of confounding factors linked to genetics. And again, that's an opinion. You can find research that would link my opinion to that. But yeah, so I don't want to rant too much longer on this. I think you've got the idea so far. There's one more thing I want to point out from this section, and that is this page. This is, again, one of my favorites, just an article coming out from some people that you would probably trust constantly, but man, did they post a bad article. So in 2000, not that one, this one. The CDC announced in 2004 that obesity was the cause of 400,000 of the approximately 2.4 million deaths per year. So in 2004, we were having about 2.4 million deaths. And the CDC, the Center for Disease Control, said that about 400,000 of those 2.4 million. Now that's 17% rounded to the nearest whole. It's 16.7%, whatever. The 17% of deaths are caused by obesity. So they published an article or announced, whatever. However, so they said causation. Obesity is causing 17% of deaths. However, the CDC did not control for a very important confounding factor. Control means a neutral value, kind of like when I said, all right, if you increase their meat intake, what about the sugar? What about their vegetable oils, things like that? You would need that to be consistent. You'd need to have people of the same biological nature, from the same region, whatever, with similar genetic compositions maybe, or maybe you need to take everybody. Maybe you need to study 100,000 people, not just 10 people, that kind of stuff. So the CDC did not take in old age. Guess what? Older people tend to be heavier. We talked about that earlier in relation to skinnier people making less money than fatter people. Well, older people tend to be heavier. It's just natural. Even before obesity rates were climbing, you just gain a little weight as you get older. It's natural. So older people tend to be heavier and also tend to die in greater numbers than younger people. So after the CDC did more research, they looked at their findings, they did more analysis, more statistics, more of everything, bigger, faster, stronger, we can rebuild it. I don't know why I'm referencing that. Anyways, after they revised all of their information, their findings, their paperwork, they revised their estimate to 24,000 deaths being caused by obesity. That is only 6% of the original number they published. That is insanity. The CDC messed up so bad that the real number was only 6% of what they had previously published. Now, did they do that intentional? I don't know. This isn't what we're here to discuss, whether the CDC puts out false information or not. I know that there's a certain person in our country right now that has an opinion about the CDC and what they're putting out with data and whether or not we're going to continue to use that data. And I am not telling you to trust or not trust the CDC. It's not what I'm telling you. I'm just giving you information and having small laughs about it. But I just think that that is absolutely insane. They had a study where they said 400,000 people were dying because they were fat. And in reality, and I say in reality, I'm just saying in their updated study, who's to say this study is right, you know? I mean, if they did it wrong the first time, only one, shame on you, right? That old saying, and not the George Bush version of it. Why could I keep referencing presidents? Anyway, so the CDC revised it to 24,000, 6% of the original number. So it turned out that 94% of the people they thought were dying because they were fat were just dying because they were old. That's bad. Now you might say, okay, well, if this is the more accurate number, at least they didn't hide it. At least they did come and publish their findings. And that's awesome. That's great. back in March, we were talking about maybe we don't really need masks, maybe we do, and now people are saying we do. So there was some change there. There has been some revisions as we have more information, as we do better research. So sometimes these things are intentional, sometimes they're not. And again, I'm not saying this 400,000 versus 24,000 was intentional. Maybe it was an accident. Maybe they were trying to fudge the numbers. I don't know. So there's some more in here, but that's just the one I wanted to pick out since it was kind of related to the Walmart one, just dealing with obesity in general. So read the rest of those on that page in particular. Bivariate data, this is kind of what we were talking about with the picture having two, I'm sorry, this is similar but not the same as what we were talking about earlier, where you've got two different charts. One of these is based on the actual prices at the time of gasoline. The other adjusts for inflation. Now, when you adjust for inflation, that means there's going to be a bigger gap in these in the past. So gas might have actually cost 50 cents back in 1976, but when you account for inflation in our dollars now, it's more like $2.50. And then we had the gas crisis of the 80s and the 70s, and the price spiked in the 80s. So even though it only went up from 60 cents to about $1.40 at its worst, if you account for inflation, it went from about $2.50 to about $3.75 at its worst. Again, thinking in terms of our dollars now. There was a lot of inflation in the 80s and early 90s, the mid 70s to the beginning of the 90s more specifically. And we've talked about that. There's a correlation, maybe even a causation to the the fact that in the 60s or 70s, we no longer backed the American dollar with gold. We went off what we call the gold standard. So now our dollar is just, it just has value on hopes and prayers and dreams, basically. Fort Knox is not backing all of our dollars, that is to say. So again, the difference of these two curves as you move on, they become pretty much the same because the dollar value in 2014 wasn't really any different than the dollar value in January 2016. Even if we zoom in, we can see that these things are almost identical as we get really close to the present. And again, because inflation was so big in the 70s and 80s, that's why these are further apart. If we kept going back into the past, these would keep getting further and further and further apart. Oh, so I wanted to talk about the relation here. So this chart is the gas prices every single month from January 76 to 2016. So these are gas prices by month. Again, green actual, blue accounts for inflation. And when you account for inflation, it doesn't feel like they move as much. We've always been around the $1.75 to $3 range when we account for inflation. So thinking in terms of an updated dollar. It definitely feels more significant when we were paying 50 cents in the past. But again, everything else was more expensive, so relative to everything else, it more felt like the gas was $2.50 a gallon. So what they do is, we're going to take all the data points, and I think they use the inflated ones. I got to confirm. Yes, so they use the inflated prices. And what we're going to do is we're going to chart them over here, or what they do, and the oil price per barrel versus the price of gas. So gasoline is refined from oil. You dig up oil from the ground, you do something at a factory, and you turn it into gasoline. So in January of 1988, here is its inflated price, and oil had a certain price per gallon then, maybe 50 bucks a barrel, maybe 30 bucks a barrel, I don't know. And then January of 2008, when we had that gas crisis because of a hurricane shutting down some pipelines, one or two of them. So gas went up to $4.20 a gallon, $4.25 a gallon, practically overnight. And then we had the economic crisis that just shut that down, and gas went to like $1.50 a gallon on average, really, really quickly. So again, oil per barrel was like 100, I don't know, 130 bucks a barrel here, and then all of a sudden it was only like 50 bucks a barrel or 40 bucks a barrel. That was a sudden change because we had an economic crash. Everything else after that's been pretty steady. These little ebbs and flows or peaks and valleys. Gasoline changes price with the season, basically. So that's what's happening there. It goes up and then it goes down. Then next year it goes up, then it goes down. So winter months versus summer months, one tends to be higher, one tends to be lower. I'll let you try and figure out which one's higher or lower. Look at gasoline for a year and see if you can figure out when it's usually higher. So oil price here may have been super high, and then oil price here may have been super low, and then oil price was super high, and then oil price was super low. So what they do is they make a chart, and it's oil price versus gasoline price. Now, these data points are not ordered in time, and they really demonstrate that with these little purple bubbles. So they say this dot somewhere over here was the February 99 data, where oil was only $14.77 a barrel, and gasoline at the pump was $1.32 for a gallon. This dot over here was June of 2008, when oil was 136 a barrel, so that was probably around the storm time, and 4.39 a gallon, so it was pretty high. And then January 1981, so this is 2008, which is not the furthest in time. We were going up to 2016. And then this point over here is 1981. So over here on the left, we got a point from 99. Here's a point from 81. Here's a point from 2008. They're again just demonstrating that these are not ordered based on time. So this point right here may be from 1976. It might be from 2012. It might be from 1983. We don't know. But again, that's not necessary. We're just charting the price per barrel of oil versus the price per gallon of gas and seeing if there's correlation, and then maybe trying to see if there's causation. So time is not shown in this scatter plot. Caution. So what these are trying to do is say, okay, if you see one thing increase, does the other increase? And pretty much these points almost follow a linear trend line, and this black line right here is Excel doing a line of best fit. And that line is pretty close to all these points. Now there's some that are a little further removed. These are a little more isolated, but they're still not that far. It's not like they're dotted over here, and over here, and down here, and here, and here. These fit a trend pretty well, which means there is correlation. As oil price increases, gas price increases. And again, this has nothing to do with time. Oil price tomorrow could drop 50 bucks a barrel, and then we'd probably see gasoline at the pump drop a proportional amount. Now, maybe it does, maybe it doesn't. Again, it's correlation, so it's not guaranteed, but it's expected. And then there's an R squared here, which again, we've talked about briefly. We will officially put in the notes in 8.3, so very shortly. R squared measures how close these points are to the line of best fit. 0.96 is excellent. That says there's a 96% correlation, basically. So in other words, a change in oil price correlates to a change in gas price on a 96% efficiency. That's basically what's happening here with that number. And again, official definition coming in hot soon. So this shows there's definitely a correlation between oil and gas. Does it show causation? It absolutely does not show causation. Do I need to go to the next page? I do not. Okay. This does not show causation at all. Data points and graphs do not show causation. Causation is the science behind everything. Causation would be us saying that oil price increases causes gas price to increase because gasoline is refined from oil. If oil is more expensive, it's going to cost more to make the gas. Now you might say, okay, well, is this, are these proportional? If I double the price of oil, does the price of gas double? And that is not true, because there are other costs associated with converting oil from gasoline. You have employees to pay, you have buildings to furnish and own, and taxes to pay, and you've got holes to dig. So if one day oil drops to zero all of a sudden, Gasoline would not drop to zero. You're not going to go to the pump and get free gasoline because they still have to pay those employees. They still got to pay the rent on the building. They still got to pay their taxes. They still got to pay to dig another hole. They still got to pay to buy more equipment. So it's not directly proportional or anything like that, but there's definitely correlation. If one of them, if all of a sudden oil doubles, the price of oil doubles, the price of gasoline is definitely going to go up significantly. I don't know that it would double. Maybe it does a little more than doubling. Maybe it does a little less than doubling. There's definitely a relationship, though, as we can see. All right. So that is 8.1. So confounding factors, these are the often hidden variables behind correlation. The confounding factor for the oil versus gas is the fact that gasoline is derived from oil. So again, the graphs show correlation, but if you want to show causation, you have to start doing analysis and talk about the confounding factors, which again are the fact that gasoline is refined from oil. What's really causing America's obesity? I kind of started trying to get into that, but I didn't make any blanket statements because I am not a health scientist. I'm a mathematician. But it definitely seems like if I were to publish an article, I would try and show the causal factor being just an increase of sedentary lifestyle as well as an increase to access to cheap, quick, arguably unhealthy food. And again, I'd have to do a lot of science to prove that statement. The graphs would be very easy to show correlation. I can correlate all day on that. But can I show causation? I'm probably going to need some PhD candidates to help me with science there. All right, so 8.3, we're skipping 8.3.